Hi everybody, today we're going to talk about identifying domain of rational functions. We just finished notes that were solving rational equations, and so in our notes on solving rational equations, we always wanted to factor the denominators and find that LCD. We multiplied all of the terms by the LCD so that we could get a nice simple equation to solve, but our last step, the one that I really want to remember, is that once we got a solution for our rational equation, we always had to check for extraneous roots, meaning we always had to check that our solution that we got when we solved was okay and was not going to make our denominator 0. So we always had to take our LCD, our least common denominator, and make sure that none of the factors gave us x values that matched our solution. So today what we're going to do is we're going to try and identify those domains of rational functions just by using the denominator and making sure that we don't get values of x that make the denominator 0. So the only x values that are not possible in a rational function are the ones that make the denominator equal to 0. All other real numbers can be used in the domain except for the numbers that make the denominator 0, because that's where you end up with an undefined point. So to find the domain of a rational function, you want to set the denominator equal to 0, factor if possible, and solve for x. Pretty much what we did in the last set of notes, just at the end of our solving process. So you want to solve for x, and whatever you get is not part of the domain, because that's what would make the domain, or the denominator 0. So to find the domain of the following rational functions on number 1, I don't have anything to factor, because x plus 2 is already a linear binomial. And so what I would do is I would take this x plus 2. I don't want it to equal 0, because if I have a denominator of 0, that makes an undefined place. So I don't want x plus 2 to be equal to 0. I'm going to go ahead and solve for x by using inverse operations, and x cannot be equal to negative 2. That's what x cannot be. So my domain is all the real numbers except x cannot be equal to negative 2. So that's what this problem looks like. Number 2, I have 2 over x squared minus, 2 times x squared minus 9 over x squared minus 4. So x squared minus 4 is my denominator. I notice that that's a difference of 2 squares, so I can make that x plus 2 times x minus 2. And I don't want this to equal 0. So I'm going to take each individual factor and I'm going to set it not equal to 0. X plus 2 cannot be equal to 0. So if I solve, x cannot be negative 2. And then also, x minus 2 cannot be equal to 0. So if I use inverse operations, x cannot be positive 2. So my domain is all real numbers from negative infinity to positive infinity, except x cannot be negative 2 or 2. You could also say all real numbers except x cannot be positive or negative 2. So that's an acceptable way to write it as well. So remember, you're only checking the denominators. The numerators, it really doesn't matter what's happening with them. All we need to know is the domains. All real numbers except the values of x that make the denominator 0. So here's my denominator in number 3. It's x squared. I don't want it to equal 0. So the only way that I can undo a square is to square root. X cannot equal the square root of 0. Typically when you square root you get a positive and negative answer, but in this case the square root of 0 is just 0. So my domain is all real numbers except x cannot be 0. Because if x were 0, 0 squared is 0, and that would be a denominator of 0. That would be undefined. So let's look at 4. Number 4, pick out your denominator, factor it if necessary, and solve. You do not want the denominator to equal 0. So take a moment to try number 4 and check back for your answer. The denominator of x minus 1 cannot be factored. So I set it not equal to 0. I solve, I get x cannot equal 1. So my domain of that function in number 4 is all real numbers except x cannot be equal to 1. Moving on to number 5, we'll do this one together, and then number 6 you'll try on your own. Number 5, my denominator is x squared plus 4x plus 3. That's a trinomial that I should try and factor with magic numbers. So I need two numbers that multiply to be 1 times 3. So they multiply to be 3, but at the same time they have to add to be 4. So the numbers that multiply to be 3 and add to be 4 would be 3 and 1. So my factors are x plus 3 and x plus 1. That's my factored denominator. Now I don't want my denominator to be equal to 0, so I'm going to make sure that I take each factor and set it not equal to 0. If x plus 3 cannot be 0, then x can't be negative 3. If x plus 1 cannot be equal to 0, then x can't be negative 1. So my domain of this function in number 5 is all real numbers, except x cannot be equal to negative 3 or negative 1. You could also write this out as x cannot equal negative 3 and x cannot equal negative 1. So you could write them separately, and that's okay. Number 6, I'd like for you to try on your own. Look at the denominator, decide what values make the denominator 0, and write your domain without those values in it. So pause your video and try number 6. Check back for your answer. So in number 6, the denominator is a difference of squares. The square root of x squared is x. The square root of 4 is 2, plus or minus 2. That's why you have an x plus 2 and an x minus 2. If I set each factor not equal to 0, x cannot have a value of negative 2 or positive 2. So the domain of function in number 6 is all real numbers except x cannot be equal to plus or minus 2. So just remember that whenever you're trying to find possible domains of rational functions, you can't have denominators of 0. So any x value that makes a denominator of 0 is not in your domain.